Good morning, students. After this Clairaut's equation reducible to Clairaut's form, now we come to linear equation with constant coefficients equation, and in this we are going to discuss an equation of second order. So here the equation is of this form: d2y dx2 plus p1y dy dx plus p2y is equal to x. Name it as equation 1, or symbolically you can write it as d2 plus p1d plus p2 into y, where d2 stands for this one, d2 dx2, and d stands for d dx, where p1 p2 are constant and x is a function of x alone. So this capital X is either a function of x alone or it is a constant. Now when the right hand side of equation 1 is 0, that is when capital X is called 0, then this equation takes the form d2y dx2 plus p1 dy dx plus p2y is equal to 0. So we take here y is equal to e to the power mx as a trial solution of this, which we get from the first order linear differential equation dy dx plus py equals 0, which is of the same form. So if you take this one as a trial solution, you differentiate this with respect to x, what you get dy dx is equal to m times of e to the power mx. Again you differentiate it 2 times, you'll get d2y dx2 is equal to m into m will give you m squared e to the power mx. Now putting these values in equation 1, not in equation 1 here, I mean in this equation 2, I can write equation 2. So what we get here is m squared, because we are replacing this by m squared plus p1m plus p2 into y is equal to 0, where y here you replace it by e to the power mx, e to the power mx equal to 0. So after substituting here, we get m squared plus p1m plus p2 into e to the power mx. And since this e to the power mx can never be equal to 0, it implies that the term inside the bracket, that is m squared plus p1m plus p2 is equal to 0. And this is called an auxiliary equation. Now from here you have to solve it, find out what are the roots of this equation. So if m1 and m2 are the roots, because this is of degree 2, so there will be 2 roots, exactly 2 roots. So if m1 m2 are the roots of the above equation, then y is equal to e to the power m1x and y is equal to e to the power m2x will be the solution of this. And it can be seen that you can express also this one in this form: y is equal to c1 e to the power m1x plus and y is equal to c2 e to the power m2x are also the solution. Now if you substitute here, the general solution of this equation now will be y is equal to c1 e to the power mx plus c2 e to the power m2x. Now there are 3 cases arise with this m1 and m2 being the roots. If m1 and is different from m2, means if these 2 roots are not equal, then they are real, mean they are real numbers, then the general solution of this equation 2 will be y is equal to c1 e to the power m1x plus c2 e to the power m2x. And if they are real, m1 is equal to m2, if the roots are equal, I mean if m1 is equal to m2 is equal to mc and they are real number, then the general solution of y will be of this form: c1 plus c2x e to the power mx. And third is if m1 m2 are complex roots, means m1 and m2 are complex number, that is of the form alpha plus I beta, and m2 is the conjugate of this, that is alpha minus I beta, then the general solution of 2 here will be of equation 2, that is of this, will be y is equal to e to the power alpha x into a cos beta x plus b sin beta x. So these are the rules to find out the solution of the linear equation of second with constant quotient, where the right hand side being equal to 0. So let us see some problems here. How we solve it? This is a given differential equation of second order. So according to that rule, here we can, you replace this d2 dx2, or you can write here this as d2 minus 7d plus 12 into y is equal to 0. Now auxiliary equation is m square minus 7m plus 12 is equal to 0 into, and by putting y is equal to e to power mx, y equal to e to power mx can never be equal to 0. It means that m square minus 7m plus 12 will be equal to 0. Factorize this using this factorization of quadratic equation. Treat this as a quadratic equation of indeterminate. Instead of x we have m, so you can write this as m square minus 4m minus factorization 3m plus 12 is equal to 0, because minus 4 into minus 3 gives you 12 plus 12. Or you can write this as m into m minus 4 minus 3 into m minus 4 equal to 0, or m minus 3 into m minus 4 is equal to 0. So therefore this implies that m here is equal to 3 and 4, and treat this as m1 and this as m2, and since the roots are real but they are unequal, m1 here is equal to 3, that is, and m2 is equal to 4, and they are unequal. So therefore the general solution will be y is equal to c1 e to the power 3x plus c2 e to the power 4x. Now if the roots are real, if suppose how this is equation 1. Equation 2, if you have d2y dx2 minus twice a dy dx plus a square y is equal to 0. So the auxiliary equation here, AE, stands for auxiliary equation, is m square minus twice am plus a square is equal to 0. Factorize this. This is of the form m minus a, that is a minus b the whole square, or you can write it as m minus a the whole square is equal to 0. So as you can see here, the roots, or you can write m minus a into m minus a. So the roots are real and equal. Means that m1 is equal to a, m2 also will be equal to a. So this implies that m is equal to a comma a. So in this case, and they moreover they are real, so therefore the general solution of the above equation will be y is equal to c1, in case, as you can see here, you see this rule. If the roots are real, then the general solution will be of the form c1 plus c2x e to the power mx, but m here is equal to a, so here the general solution will be c1 plus c2x into e to the power ax. So this is the equation. Now in case if the roots are, if you have an equation of this form in complex form, that is d2y dx2 plus 16y is equal to 0, then what is the auxiliary equation of this? This is of the form m square minus 16 plus 16 into y is equal to 0. You can express this in this form, and the auxiliary equation here will be m square plus 16y is equal to 0, which implies that m here will be equal to plus or minus 4i, that is imaginary roots. So since there is no real part in this, what we get is, therefore the general solution, you have to use this third condition. If m1 and m2 are complex roots, take m1 is equal to alpha plus I beta, but here in this case we have m1 is equal to 4i, that is beta is equal to 4, where alpha is equal to 0, and m2 is equal to minus 4i, means alpha is equal to 0, means only the imaginary part is there. So what will be the roots here? It will be e to the power alpha x, but alpha here in this case it is equal to 0, so we get general solution is y is equal to e to the power 0x, okay, into a cos of 4x plus b sine 4x, that is beta x, and e to the power 0 is equal to 1 only, so therefore the general solution in this case will be a cos 4x plus b sine 4x. So this complete the proof of this. Okay, I hope it is clear to you.